Hi, my name is Jane. Thank you so much for making the time. Let's get started. We'll be spending about 30 to 40 minutes to go over a few recursion problems. APCSA doesn't require you to write a recursive method, but it will ask you to track them. So we'll be practicing a lot of code tracing today. If you have a paper and pencil, please have them prepared. And if you catch me making any mistake, please type it in the chat window. What is a recursion? Recursion is a process of repeating instructions in a self-similar way. What does that mean? Let's look at a simple example. I'm going to do a search on Google for recursion. What does that give me? Did you mean recursion? Did I misspell it? Let's click on the recommendation. Oh no, not again. What's going on here? Let me click that again. And it looks like I am stuck here. I'm stuck in a repeated process that I can only get out of after realizing that this is an Easter egg from Google. Let's now look at a code example. I'll jump to PopFizz to pull up my editor. Those of you who have signed up on PopFizz, you also have access to this editor from the APCSA course. I'll go to the last menu item for my editor. It's already got some code in there. Let's take a look. There's the main method that calls a method called -1 and then passes in 10 as its parameter. Below that, we have the method -1, which is going to return an integer type, which will be -1 passing in n-1. So we see that this -1 method is calling itself at the return statement. I'm going to give you a minute to take a look, and in the chat window, tell me what is the result of running this code. Ready? I'm going to run it now. Let's look at the results. Oh no, something went wrong here. Let's scroll to the top to see what the error message is. It looks like there was a lot of repeating method run here. And the error message says Stack Overflow error. This means that there were stack of to-dos that Java just gave up on doing. And that is because this is infinitely calling itself. If we actually want to check what this is doing, we can insert print statements. Let's do that. Clear the result window and run. So we see the error now. Let's see what it printed before that error. So we can see that integers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2, and so on has been printed until Java gave up on processing and threw a Stack Overflow error. Okay, so how do we fix it? And we want to fix it so that the code prints integers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 in this descending order. In order to control a recursive method, we need a base case. And base case works like a break. So let's insert that base case, and I will remove the print statement for now. And let's get started. Clear the screen. We're going to add a base case that says if n is less than or equal to 0, and of course you can insert spaces if you'd like. Open a curly brace, return n. So this means that if n is equal to 0, then return 0. And your method call will be completed when you run the return statement. Else, open the curly brace. I'm going to copy this return statement and insert it in the else statement, which is saying if n is not less than or equal to 0, then keep calling -1 method and pass in n-1. So you can imagine if we start with 10, right? Then the next call will be 9, and that 9 is going to be passed in as a parameter, which is then going to go to that last line and return -1, 9 -1, passing in parameter value of 8 and 7 and 6 and so on until n is equal to 0. Let's run this. And of course you won't see anything because we don't have any print statements. So let's insert them. System.out.println n, and also have one in here. Copy this line. Run. And there we have it, 10.9.876543210. Now be careful where you insert your print statements. These print statements are excellent for testing out your code. Sometimes you'll insert the print statement after the return statement. And if you do that, you will never reach your print statement ever because it's after the return statement, and you'll get an error. Let me just show that to you. Yes, so as you can see, unreachable statement. Make sure to insert it before the return statement, because once a method returns a value, then that method call is done. And another thing that I wanted to show you is simplifying this code. So in your APCSA exam, of course, you're not going to see these print statements because you'll have to trace it without being able to run the code. So you can simplify this code by removing some of the curly braces here. A single line of instruction in a code block doesn't need curly braces. So let's remove these here. We can simplify this even more by removing the else statement. And this makes sense because that if statement is going to be executed when n is less than or equal to 0, and any other value of n will skip the whole if statement and reach that last line where it returns -1 and -1. Now let's take a look at our first question. What is returned by the call re with parameter value of 5? Note that we have a base case that will run when n is equal to 1, and it will return 1. Then we have a return statement that works towards the base case, which will return n times method call re that passes in n-1. So I'll give you a minute to take a look. If you know the answer, please type it in the chat window. We're going to trace the code by first rewriting that last return statement below here. N times re n-1. And value n begins with 5. So we know that it does not meet the base case condition. So it will fall right to that last statement, which is return n times re, passing in n minus 1. That'll be 5 times re 5 minus 1, and begins the rabbit hole. We're going to trace this recursive call, which is going to be re, passing in value of 4, and now n is assigned 4. And 4 is not 1, so once again, we run that last return statement, which is going to be, this time n is equal to 4. So 4 times re 4 minus 1 is executed. And we once again have a recursive call here. Now our n is equal to 3. So this call, because n is not 1, is going to execute that last return statement, which is going to be 3 times re 3 minus 1. 3 minus 1 is 2, and once again, it is not 1. Trace the recursive call again, and because n is 2, we execute that last return statement. 2 times re, pass in 2 minus 1. Great, now we have n, which meets the base case. So notice that we have 5 times recursive call, 4 times recursive call, and so on. And these 5 times, 4 times, 3 times, 2 times, these instructions haven't been executed yet. So it's waiting for that recursive call to end. And because now we've hit our base case and this recursive call returns 1, we can now collect all the instructions that are waiting to be executed. So let's collect it going upwards like this. So that's going to be 1 times 2, right? Did this. Then take care of 3. Take care of 4. And take care of the last one. Multiply by 5. And this equals to 120. Great. Do you recognize what this algorithm is? You might have seen this in math. So in math, this is expressed as n exclamation mark, which is the factorial exclamation mark. So factorial recursion is a popular one that you'll see in many Java recursion examples. And basically that is n times n minus 1 times n minus 2, so on, till times 1. Great, now let's take a look at question number 2. Question number 2. What is returned by the call re passing 5? And this one's a bit challenging because we have a return statement that makes 2 recursive calls. And the first one passes in n minus 1, the second one n minus 2. So I'll give you a minute to take a look. If you have an answer, please plug it into the chat window. So for this one, we're going to need a lot of space. So I'm going to write our last return statement on the top. Re n minus 1 plus re n minus 2. And our n value will start with 5. And 5 does not meet the base case, so we execute the last return statement. So this will give us re 5 minus 1 plus re 5 minus 2. And now we have 2 rabbit holes to take care of. And this will keep expanding. And next, n is now 4 for the left side. We'll take care of the left side first. And 4 does not meet the base case, so we're going to execute the last return statement, which will give us re 4 minus 1 plus re 4 minus 2. All right, more rabbit holes. Once again, let's take care of what's on the left side. 4 minus 1 is 3. So your n value right now is 3, does not meet the base case. So we execute the last return statement. And this will give us re 3 minus 1 plus re 3 minus 2. And to make this a little more simple to track, I'm going to add these lines so that we don't miss anything. Re 3 minus 1, n is 2. And 2 does not meet the base case, so once again, another rabbit hole. Re 2 minus 1 plus re 2 minus 2. Now we've hit our base case. 2 minus 1 is 1. 2 minus 2 is 0. Now because n is equal to 1, we're going to return n, which is going to be 1. And the right side, yes, 0 is less than 1, so we'll return n, which is 0. Excellent. Now let's take care of re 3 minus 2. And 3 minus 2 is 1, and 1 hits the base case. And return n, which is going to be 1. We still have re 4 minus 2 to take care of. And 4 minus 2 is 2. Does not meet the base case, so it's going to call re 2 minus 1 plus re 2 minus 2. Hit the base case for the first one, so this one is going to be 1, and this one is going to be 0. So this whole re n minus 1 side has been taken care of. And we have 1, 0, 1, 1, 0 that we need to add. So this will give us 1 plus 0 plus 1 plus 1 plus 0, value of 3. Now let's take care of re n minus 2 side. We started with n equals 5, so 5 minus 2, re past 3, and n equals 3 does not meet the base case. Let's go to the return statement at the end. This will give us re 3 minus 1 plus re 3 minus 2. 3 minus 1 equals 2, does not meet the base case, so the last return statement will be re 2 minus 1 plus re 2 minus 2. Re 2 minus 1 is equal to 1, 2 minus 2 is equal to 0, and your return values will be the same. Now let's take care of the right side. Re 3 minus 2 n is equal to 1 meets the base case, so returns 1. That was simple. So let's collect all the return values, 1, 0, 1, and add them up. 1 plus 0 plus 1 equals 2. And last step, add 3 plus 2, we get 5. Do you recognize what this algorithm is? You've probably seen this in math. So this is a Fibonacci question where you add the sum of two previous values. Next question. What is returned by the call re5? This one has a base case where if n is less than or equal to 1, it will return 1. Else, it'll return n plus re, passing n divided by 2. So I'll give you a minute to think about it. This was pretty simple. Let's first rewrite the return statement and start tracing with n equals 5. And this does not meet the base case, so we execute the last return statement, which is going to be 5 plus re, 5 divided by 2. An integer division, 5 divided by 2, is going to give us 2 because it will truncate or chop off the decimal values. This will equal to re 2. Now our n value is 2. 2 does not meet the base case, so execute the last return statement, which is going to be 2 plus re 2 divided by 2. And 2 divided by 2 is equal to 1, which meets the base case. So we return 1. Notice that we haven't taken care of 5 plus nor 2 plus at this point. So we're going to collect it now that we have finished executing our recursive calls. And let's collect them from the bottom. So 1 plus 2 plus 5 will be our answer, which is equal to 8. Next question. Just 2 more to go. Hang in there. The question is, what is returned by the call refizz? So this question requires you to know how to work with string methods. So this method, re, will take in string t, and the base case will take the length of string t. If that length is greater than 6, then return that string t. Else, make a method call to re again by passing in string t, concatenate or add it with t.substring, pass in t.index of zz. So before jumping into code tracing, let's figure out what this means. So from t plus t.substring, t.index of zz. So t.index of zz. First of all, let's look at the word fizz. And the length of fizz is 4, right? We have 4 letters, and each letter has an associated index number, 0, 1, 2, 3. An index of zz is going to return the index value of zz. So this is going to be 2. Great. Now let's take a look at the next part, substring. So substring 2, or a substring of where zz begins, this is going to be your start index. And because the end index is not specified, it's going to give you substring start index to the end. So basically, this will return zz. And then add that to fizz, which is going to be fizz plus zz. Now that we know how this works, let's start tracing. So I'm going to write that return statement at the end, t plus t.substring, t.index of zz. So we start with string t equals fizz, and that is going to be re fizz. From here on, it's going to be mix of code and pseudocode plus, and then t.substring, t.index of zz. We know that index of zz is 2, right? So substring 2 is going to give us zz. Another call to re. This time we're passing in fizz with 4 z's, and this has character length of 6. Ooh, edge case. We're comparing this against 6. Do we meet the base case? 6 is not greater than 6. Let's execute that last return statement. This time with fizz with 4 z's. Re, fizz with 4 z's, plus index of zz. And of course, it's 2 again. And substring, starting from 2 to the end, is going to give us 4 z's. And now our string t is fi with 8 z's. Is that right? Now we meet our base case. Return fi 8 z's. Last question. What is returned by the call re30? This one's a bit tricky because if you look at the last recursive call, we have a recursive call inside a recursive call. So I'll give you a minute to take a look. So let's begin by rewriting the last return statement. And begin with n equals 30. And 30 does not meet the base condition, so we'll execute the last return statement. Well, this looks like there's a lot happening here, but don't worry. We're going to take care of what's inside the parentheses first. And trust that this will take you somewhere and it will stop at some point. So, 30 divided by 5. 30 divided by 5 is 6. And our n value for this inside recursive method call is 6. Therefore, it meets the base case. So this whole recursive method call inside the parentheses is going to return 6 times 3, which is going to give us 18. We still have the outside recursive method to take care of, and our n value at this time is 18. So re18 does not meet the base case, so we are at the last return statement where it is re18 divided by 5. Once again, work with what's in the parentheses first. 18 divided by 5 will give us 3, because integer division truncates or cuts off the decimal values. We have a recursive call to method re passing in 3, and 3 is less than 9, which means that the inside recursive call is going to give us 3 times 3, which is going to be 9. Once again, we have to take care of the outside recursive call, and we're passing in 9. An edge case, is 9 smaller than 9? No. So once again, we have to go to the last return statement, which is going to give us 9 divided by 5. Another integer division. 9 divided by 5 is going to give us 1. And the inside method called re1, because it meets the base case, right? N is equal to 1. 1 times 3 is going to return 3. Now we need to take care of the outside recursive call. N equals 3. Re3 meets the base case. Yes, we've reached the end of the recursive call finally. N is 3, so we do 3 times 3, which will give us 9. And our answer is 9.